Hello everyone. Today let's solve the Leetcode problem number 417. Pacific Atlantic water flow. So what the question says, there is an M into N rectangular island that borders both the Pacific Ocean and Atlantic Ocean. So that borders both Pacific and Atlantic Ocean. The Pacific Ocean touches the island's left and top edges. They have shown the same in the example. So let's come to that later. Also, and the Atlantic Ocean touches the island's right and bottom edge. And the island is partitioned into a grid of square cells. You can see the square cells, grid of square cells. You are given an M into N integer matrix heights, where heights of RC, row and column. RC is nothing but row and column. Represents the height above sea level of the cell at the coordinate RC. So just remember, this one represents the height above sea level of the cell at coordinates R and C, nothing but the row and column. So just remember this one. And the island receives a lot of rain, and the rainwater can flow to the neighboring cells directly north, south, east and west. If the neighboring cell's height is less than or equal to the current cell's height, then water can flow from any cell adjacent to an ocean into the ocean. Yeah. So just remember this one. This is very important. So the island receives a lot of rain, and the rainwater can flow to the neighboring cells directly north, south, east and west if the neighboring cell's height is less than or equal to the current cell's height. Water can flow from any cell adjacent to an ocean into the ocean. So this is fine. Next, what we have to return, they have given in the last sentence. Return a 2D list of coordinates result, where result of I equals R and C that denotes the rainwater that can flow from cell R and C to both Pacific and Atlantic Ocean. So we have to return the mainly 2D list of grid coordinates denotes the rainwater from the cell R and C to both Pacific and Atlantic Ocean. This is important. So finally we have to return the rainwater that can flow from the cell R and C to both Pacific and Atlantic Ocean. Let's consider this example and try to understand. Right? Just give me a second. Let's consider by taking this example. So what is our main objective? Our main objective is to identify the cells that can flow to both the Pacific top left, this one, top left one, and the Atlantic bottom right one, right? So Pacific and the Atlantic Oceans. What strategy that we can opt? Either we can go with the DFS approach. First, we will start the DFS from the edges connecting to the Pacific and Atlantic. For each cell, this one, for each cell, when I say this one, each individual cell, we will check if it can flow water to the ocean based on the height. That's what they had mentioned in the question as well, right? Water flows from high or low. High to low or equal height, right? So that's what they have mentioned. So let's maintain the two grids. Nothing but one is for the Pacific and one is for the Atlantic to mark the cells that can flow to each ocean. So next, for the Pacific ridge, what we will do? We will start the DFS from the top row. Nothing but we will start with this one, 0, 0. So for the Pacific ridge, we are starting from the top row and the left column. We are starting from here, right? Basically 0, 0. This one. And water can flow either right or down. We will carry on the DFS for the same, for the Pacific ridge. For the Atlantic ridge, what we are doing? We will start the DFS from the bottom row and the right column. Nothing but this one. The first one we are opting is this one. Nothing but 4, 4. Water can flow left or up initially, right? So this water can flow up or left. This one for the Pacific ridge, water can flow right or bottom down. So just give me a second. So the cells that can flow to the Pacific are this one. One is 0, 0 and this one 0, 1. This one will also. And when we perform the DFS, we will check, right? So I'll not be showing everything, but I'll just show the cells that can flow to the Pacific, right? 0, 1, this one will also flow to the Pacific, and 0, 2, this one as well. This one will also flow to the Pacific Ocean. 0, 3, this one will also. Then 0, 4, this one also will flow to the Pacific. So next 1, 0, this one, all the edges we are taking. 1, 1, this one, 1, 1. Again, I am telling not 2, 0. This one will be 1, 1. Next 2, 0. This will also flow to the Pacific. And 3, 0 and 4, 0. Nothing but these two. So this will flow to the, this one will flow to the Pacific, right? These are the cells that can flow to the Pacific. So for the Atlantic reach, we are starting the DFS from the bottom row and the right column. Nothing but we are starting from here. Let's check what are all the cells that can flow to the Atlantic. Nothing but the first one is 0, 4, this one, right? 0, 4, this one, and 1, 3, this one. 1, 3 is but nothing but this one. This can also flow from, this cell, this also flow to the Atlantic. Next, 1, 3 and 1, 4. Next one, this one also. Next, 2, 2, this one. This one as well. Next, 2, 3 and 2, 3, this one next to it, right? This one will also flow. This can also flow to the Atlantic. Next, 3, 1, 3, 2 and 3, 3. This one, 3, 1, 3, 2, 3, 3, 3, 4 as well, right? This is for the 3, 4. Next, 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. This one, this entire one. 0, 1, 2, the last row, entire row. This one, right? 4, 4. This, we are individually considering the cells that can flow to the Pacific that I have showed. The last edges, these edges, and this one, 1, 1. And this one also I showed. The cells that can flow to the Atlantic. So, these are the cells that can individually flow to the Pacific, as well as that cell that can individually flow to the Atlantic as well. Next, we will see the cells flowing to both the oceans. Which are all the cells that will be flowing, that can flow to both the Pacific and Atlantic oceans. I'll just delete this one. 0, 4. So basically, just give me a second. So we will see what are all the cells that can flow to the to both the Pacific and Atlantic. First one is 0, 4. Nothing but this one. 0, 4 can flow to both this one, Atlantic as well as the Pacific, right? So then 1, 3. This one, 1, 3. Nothing but I just mark this one entirely. So we will come to know this one, this one, and just in this case I'll just give this one, and also 1, 4. This is next one, this one, right? Just give this one, 1, 4 as well. Next, 2, 2. This one, 2, 2, and the 3, 0. Nothing but this one, 6. 3, 0, 3, 1 and 4, 0. Nothing but this one and 4, 0. Finally, this one, 5. So this one, and this one as well, right? So finally, the cells that can flow to both the Pacific and Atlantic, this one are Atlantic oceans are 0, 4, nothing but 5, 1, 3, 1, 4, 2, 2. So this one, 2, 2, nothing but 5, this one, and 3, 0, 3, 1, 6 and 7 here, and finally 4, 0. The same thing we have got in the output, right? So same thing. I'll just delete this one. So the final output the cells that can flow to both the oceans was same to the output that we got, right? So I'll just close this one. Let's try to implement the same through the JavaScript. So first what I'll do, I'll just come here. And let's initially, what shall we do? Let's check if the input matrix is completely empty. If it is empty, then we will return the empty array if true. Nothing but if not of matrix length, then what we will do? We will return empty. Then we will get the number of rows and columns in the matrix. This is easy, right? We'll just give, let me give correctly, number rows equals, this one will be length of the matrix, let number of columns, matrix row, third length. This is fine. Next, let's create the 2D arrays of the same size as the input matrix. So here we need the 2D arrays, right? Here you can clearly see. So that is the reason we are. So just give me a second. We are giving the input in the 2D arrays. So we will create two 2D arrays of the same size as the input matrix. So why we are doing that? It will help us to keep the track of whether a cell can reach the Pacific or this one, Atlantic Ocean. So this will be easy. So I'll just give let for the Pacific initially, Pacific Ocean. Let me give new array. So this A has to be capital. Array, number of rows. Let me make use of fill. Not filling anything. We're just leaving this one empty. Let's map this one. So I'll just take array of here. Let me give number of columns, and initially we will fill everything with false. So let me give fill of false. This is fine. Let me copy the same thing and make the necessary changes. So I'll just come here. Let me change this one to Atlantic. So new array of, this will be number of rows itself. Number of rows itself. That's what we have taken here, right? This one, the variable name. So fill map, this will be same. Here, this will be again number of columns itself. Initially, we will fill this one with void. Both same, right? Almost same. Next, let's consider the helper function. Let's take the helper function or create the helper function to perform depth first search DFS on the matrix. While explaining this example, I said we will be performing the DFS. For the Pacific, we will be starting from this one, 0, 0. And for this one, Atlantic Ocean, we'll be starting from the bottom right. Nothing but 4, 4, 4, right? This one is 4, 4 itself, I think 0, 1, 2, 3, 4. Yeah, 4, 4. Right? For that one, to perform the depth first search, nothing but DFS on the matrix, we'll be creating the helper function. And just come here. Let me create function DFS of row, column, current, and ocean. Sorry, I misspelled it, right? So first what we'll check, if the current position is out of bounds, then we will return nothing. So if it is out of bounds, we'll not return anything, right? Then I'll just make use of the if condition. If r is less than 0, shouldn't be less than 0, or column is also less than 0, or greater than or equal to of rows, or C greater than or equal to number of columns. So they are not returning anything. I'll just give a return. So if the current cell's height is less than previous cell, then also we are doing the same. We are not returning anything. So this is one condition. If we have considered matrix, right? Matrix is the parameter. I'll just give, matrix of row and column. If this one is less than the current value, then also will not return anything. This is one thing. Next, if the current cell has already been visited in the current ocean, then also will just return. So whatever the cell that we have already visited, we will mark that cell as visited. So next time when we visit, we will not consider that one. So it will will not be considering that one basically. So I'll just again make use of if condition. Ocean, let's see, then return. Finally, one more thing is we will be marking the current cell as visited for the current ocean. Whatever the current ocean we visit, like if we are here, suppose if we are in the 0,1, this one too. If we have visited this current ocean, if you are visiting the current ocean now, if you have visited that, we will be marking this one as visited, right? So for that one, we'll be making use of the Boolean expression. I'll just give ocean of RC. Initially, I'll set this one to true. So till here, this is fine. Next, what we will do, we will explore the neighboring cells in all the 4 directions. When we are performing this one, DFS, we are performing the DFS to the at least this one. If you are performing the DFS to this one for the first cell, then we will check for right, left. There is no left. There is no left, and there is no up also. There is no value. This is the first value, right? This will be right hand. So we'll be performing in 4 directions basically for every cell. So how can we do that? I'll just come here. Let me comment this one and write for this one. Just for the reference, explore the neighboring cells in all 4 directions. That is down. So I'll just let me write this one. We'll be making use of the recursive functions, right? So let me copy this one. DFS of R plus 1. First we are moving down, right? So this one in matrix of R C ocean. This one, let me copy the same 4 times and make the necessary changes. So this will be, this has to be R minus 1 C, matrix of RC and ocean. Next one should be R and C plus 1. So I'll just delete this one. I just change this one to C plus 1. This is fine. Finally, this has to be R and C minus 1. And matrix of RC and ocean. So move down. This one up. This one. This one left. Just give me a second. This one left. This is fine. Next, what we'll do, we'll start the DFS from all the cells adjacent to Pacific Ocean, left and top edges. First, we'll start the DFS from all the cells adjacent to the Pacific Ocean, left and top edges initially we'll be doing. So I'll just consider for loop. This will be easy. So for let column equals 0 initially, column less than this one. Let me copy this one. It's the same thing over here. Next, top row. For the top row, what can we do? We'll be performing the recursive, this one, right? Search. Initially, it will be 0, then column, and let me give number null safe. Let's make use of the min safe integer. Also, this is for the specific, right? Nothing but the top row, this one we are considering. Nothing but the specific, for the specific question, right? So next, for the bottom row, Atlantic. So this one, bottom row, the last one, right? It starts from 4, 0, if you remember. Yep. Let me give DFS of initially number of rows minus 1. Nothing but here. From here we are starting, if you remember, right? 4, 4. Number of rows minus 1. Column. And again, let me copy this one. About min safe integer. This one is fine. Finally, instead of specific, I'll just take this time Atlantic. This is fine. What we have done here, we have started the DFS from all cells adjacent to the specific question. So next, we will start the DFS from all cells adjacent to the Atlantic question. Let me comment here so that this will be easy to understand. For my reference, start DFS on all cells adjacent to the specific portion. So basically this is left and top edges, right? And top edges. This one. Let me copy the same thing. Entire line. Here what we'll do, we'll start the DFS from all the cells adjacent to the Atlantic question, right? And the bottom edges we'll be considering, right? So let me copy the same thing. Here let me change this count to Atlantic. So here let me give, instead of left and this one top edges, we are going for the right and bottom edges. So basically we are starting from here, right? Right and the bottom edges. This, so I'll change it to right and bottom edges. This is fine. Then what I'll do, same thing for, let me make use of the for loop. Row equals 0, row less than row of rows, row plus plus. This is fine. Again, we'll be making use of the recursive function. This will be row 0. So I'll copy the same thing, number dot min set integer. Let me copy the same thing. Instead of column, we are making it to row. So you can just copy paste. I'm just typing. So I make the necessary changes. So this will be specific. And let me copy paste this line and make the necessary changes. DFS of, initially it will be row. After row, instead of 0, this time it will be number of column minus 1. This will be same thing, and instead of specific, we will change this one to Atlantic. So this is fine. Then what we'll do, we'll initialize an empty array to store the result. So we have to store the result, right? So for that one, first we will initialize the empty array. Simple. So let the result equals, I'll just take this one. Sorry. Yeah. This is fine. Next, let's iterate through the each cell in the matrix. In the matrix, we are iterating through the each cell. So this consists of both, right? Specific and Atlantic. So let me consider for loop equals 0 of next for at j equals 0 Next, if a cell can reach both the Pacific and Atlantic Ocean, so we will be adding it to the result. So I showed you what are all the cells that that we had marked to the Pacific Ocean, and what are all the cells that was able to float to the Atlantic Ocean. And finally, I had even show you by taking this example itself, what are all the cells that went to, that can be added to this one, that both flew into Pacific and Atlantic Ocean. So if a cell can reach both the Pacific and Atlantic, then we will be adding to the final result, right? So for that one, I just be making use of the if condition. Yes, Atlantic, let me consider IJ, and Pacific, IJ. This is simple. What we are doing, we'll be pushing into the result, right? So let me make use of the push operation, and I comma j. This is simple. So after this, what we will do, just give me a second. Let's return the result array which contains the coordinates of all the cells. So this one, finally, we will be returning the result array which contains the coordinates of all the cells, right? All such cells. Let me give return result. So let me format this once. This is fine. Let me hit the submit. So here, unexpected token equals it is showing, right? So with the line number 20. So this has to be unexpected token or yes, this has to be, sorry, I didn't see this one, r less than 0 row initially. So here line number 28, that column, so then identify a column has already been declared. I just come here, line number 28. What did I do wrong? So what I have done is here, I have used the comma right instead of semicolon. This is fine. This is frustrating sometimes. So let me hit the submit again. So this works correctly, right? So instead of semicolon, I had used the comma, right? So this is fine now. So I had explained you with the example as well, right? So what will be the time complexity and the space complexity? So the time complexity, overall time complexity would be big O of m into n. Why the time complexity is big O of m into n? Because we are iterating over the entire matrix twice. Why we are iterating the entire matrix twice? Once for the Pacific and once for this one, Atlantic, right? So during the DFS process, we are iterating over the entire matrix twice. Nothing but once for the Pacific and once for the Atlantic. And each DFS visit can visit up to m into n cells, where we know that the m is number of rows and n is nothing but the number of columns. So the total, the overall time complexity would be big O of m into n. Let me come here. Let me give time complexity big O of m into n. And what is space complexity? What will be the space complexity? The space complexity is also big O of m into n. Why the space complexity is big O of m into n? Because the space complexity, due to the space needed for the Pacific and Atlantic arrays. And we are also making use of the recursion stack, if I'm not wrong. This one here, we are making use of the recursion stack as well. So the overall space complexity would be big O of m into n. So I'll just give here big O of m into n. So this is fine. Let me comment this one. So let me hit the submit again. So this is in correctly, right? So this is it. Thanks for watching, guys.